Hi AP Calc students, I'm going to show you how to work problem number 1 on the 2022 AP Calc AB FRQs. Problem number 1 says, from 5 a.m. to 10 a.m., the rate at which vehicles arrive at a certain toll plaza is given by this function, A of t, where t is the number of hours after 5 a.m. and A of t is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Part A says, write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. And if we're asked to find the total number of vehicles, and they've given us a rate function of vehicles per hour, then what I have to do to get the number of vehicles over that time interval is just to integrate the function. So I'm going to integrate A of t dt from 1 to 5. That will give me the total number of vehicles that arrive at the toll plaza. I do not need to put the 450 times square root 0.62 of sine of 0.62t into the integral. I can just refer to the A of t, and that's fine. Part B. Part B says find the average value of the rate. The average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza over that same interval 1 to 5. If we're going to find the average value of a function, regardless of what the function may be, in this case it's a rate, we're going to integrate over the time interval that we want the average and then divide by the time interval. It would look like this. That is the average value of A of t over the interval 5 to 1. In this problem, we actually did need to find the number of vehicles per hour, so we do need to use our calculator to integrate this function. On my TI-84, I've already entered in the function A of t. I've also made sure that I am in radians mode. Actually, now I'm in radians mode. And then what I can do is I can put this on my calculator using Math 9, which is the numeric integration function. And that's our answer, 375.537. And we're done with Part B. Part C says, is the rate at which vehicles arrive at the toll plaza at 6 a.m. or t equals 1 increasing or decreasing? Give a reason for your answer. If I'm trying to find if a function happens to be increasing or decreasing at a specific moment in time, then what I'm going to do is I'm going to take the derivative of that function, evaluate it at that time, that specific value of x, or in this case t, and I want to see if it's positive or negative. Positive derivatives would tell me that my function was increasing. So what we have to do here is we have to take the derivative of A of t with respect to time. And so we're going to take the derivative of A of t with respect to time and then evaluate it at t equals 1. We're going to use our TI-84 to accomplish this. And there's our answer. Our answer to this is 148.947, and we're really not interested in the number itself to answer this question. We just want to see that it is a positive value. That would mean that the rate at which the vehicles are arriving is increasing at t equals 1. So I would write my answer like this. And that is my answer, saying that the rate at which the vehicles are arriving is increasing at t equals 1 at 6 a.m. And my reason is because a prime of 1 is greater than 0. Part D. A line forms whenever A of t is greater than or equal to 400. The number of vehicles in line at time t for t a to 4 is given by another function n of t, which is the integral from a to t of a of x minus 400 dx. where A is the time when a line first begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time interval A to 4. Justify your answer. When we first read this problem, we realize that we're trying to find the maximum number for n of t, because that represents the number of vehicles in line. And I want to find the maximum value of that over a closed interval. So what I'm going to do is I'm going to use the extreme value theorem that says that if my function is continuous over a closed interval, there will exist at least one moment in time, or there will be one value of x, or in this case t, for which the function has both a maximum and a minimum. Now, where those are located is going to be either at the endpoints of the closed interval or at the critical values that might exist for that function within that interval. So we're going to, first of all, establish that we're going to use this theorem, and we're going to say the following. So we've established that there is going to be a maximum value. And now what we have to first do, though, is find out what is the value of a over which we're going to evaluate this function. Well, a is the time when the line first begins to form, and the line will form when a of t is greater than or equal to 400. So what I'm going to do is I'm going to graph my function a of t, and I'm going to graph the line y equals 400, and then see where they intersect one another. And that will tell me the first time that they intersect, that would be the value of a, which would be the moment in time when the line first begins to form. This point here is going to be the point that I'm interested in. That will be the value of a when the function that we're looking at, the curved function, which is the a of t, the rate at which vehicles are arriving, that's when it is equal to 400. And we can see here that that value of t, actually the value of t, which we're calling a, is 1.46937. Now what we want to do is find what are the critical values that might exist for n of t over the interval 1.46937 to 4. As that is the interval that we're going to evaluate. I will then take the derivative of n of t and set it equal to 0. When I take the derivative of n of t, remember that using the fundamental theorem of calculus, we are just going to be replacing the upper limit of my integral t in for the variable x, and then that will become my derivative. Because when I take the derivative of an integral, they just reverse each other. They are inverse operations. One common mistake that probably students will make on this particular problem will be to consider this to be 0, like they're taking the derivative 400. Actually, this entire function, because it's the integrand, is going to be the derivative. Once I take the derivative of n of t, it will wipe out that integral, and we have our n prime of t as a of t minus 400. When I set that equal to 0, then I realize that the other critical value would be any time in my interval where this is true, which takes me back to my calculator. And I'm interested now in this other intersection point because that would be a critical value. So what we're going to do is we're going to figure out what that is. And we can see that there is a critical point, a value of t at 3.5977, at which the function n of t, at which its derivative is equal to 0. And that becomes then a critical point for me to evaluate. This means that I'm going to use the candidates test because I now have 3 candidates where the maximum value for n of t might occur. Those values are the following. They are the 2 endpoints, which are 1.4 0.46937 and the critical point 3.5977, and then the other endpoint, which was 4. So now what we're going to do is evaluate n of t at each of these candidates. And remember what the function is. Here is n of t. It's the integral from a to t. Well, a we've already established is the 1.46937. So that means then that if I'm going to find the number of vehicles in line, I would be integrating from 1.46937 to 1.46937. And that would be the integral of a of t minus 400 dt. Well, that's obviously 0 because I'm integrating from one value to the same value, so that is a 0. The next thing that I will do is integrate. I'm going to find n of 3.5977. And by the way, this is a of x, right? That's the dummy variable that we're using here. So that was a of x. So I am going to integrate this using my calculator. And there's my answer, 71.254. And lastly, I'm going to evaluate at time t equals 4. And I'll use my calculator. And I get 62.338. This is the maximum value of all three. And so I can say then the maximum And that concludes that problem. I hope you found this helpful. If so, hit the like button and feel free to subscribe to my YouTube channel. Thank you very much.